Welcome back, everybody. We're going to go into part 2 of air systems now. So, hope you enjoy. Thanks. Okay, it's not hard to figure out. Okay, home stretch, guys. Home stretch, I promise. Alright, so we get here to equipment cooling. I am not going to go through the whole spiel of what the equipment cooling system and how it works and all that stuff. I'm simply going to talk about lights and the switch. Okay, so if we come back and we look, bring up all of our lights again to the test. First thing you're going to notice is cooling. Yeah, they misspelled that. There's only one L, not two, but it's fine. You also notice that we have valve, overheat, and smoke. So, what do they mean, and what happens when I move this switch? Valve light, that tells me that a valve's open when it should be closed. That's going to be either my overboard exhaust, my inboard supply, my smoke override valve. One of those is going to be open when they should be closed. Why is that a problem? The overboard exhaust is a giant hole in the bottom of the airplane. And I know we haven't covered pressurization yet in this video, but having a big hole in the bottom of the airplane is not necessarily a good thing. It is hard to pressurize when you have a big hole in the bottom of the airplane. So, what do we want to do to fix that? We go to standby. Standby does two things. And it, again, follow your QRH. I can't say that enough. Follow the QRH, follow company procedure. But I'm going to tell you what it does. I go to standby. It sends a signal to all the valves to get in the position they're supposed to be in, first off. And the second thing it does is it switches a fan. It turns one fan off, turns one fan off, turns one fan on. Okay. So, valve light illuminates, I go to standby, hopefully that fixes it. If not, I gotta follow the QRH to do something else. And hope I pressurize. Overheat. So, I normally have a fan running that helps pull the air through the equipment cooling system when I'm in flight. If that fan, for whatever reason, fails and it gets hot in that system, I'm going to get an overheat light. Again, I'm going to go to standby because what does standby do? It turns off one fan and turns on another one. So the idea is that if the fan that's supposed to be running has failed, when I go to standby, that it'll turn on the other fan and it'll help pull that air through the system and it'll allow me to get cooling in that area. So, when I go to standby, the overheat light is going to be inhibited to come back on 5 minutes. Okay? So, standby, overheat light's inhibited for 5 minutes. It waits and waits and waits. And then, after 5 minutes, if the temperature is too high, overheat light comes back on. And now I've got to go somewhere else to do something else. Okay? Smoke light. Self-explanatory, kinda. Means there's smoke in the system, right? Follow the QRH. It's going to have you go to the override position. The reason it has you go to the override position is because what it does. It opens the smoke override valve on the left side of the airplane. And if you remember, I've discussed this. I haven't been able to show it because I can't find a good picture of it. If you fly a 7.6 and you can get me a good picture of the smoke override valve, and you want to send it to GSI Guy Brandon at Gmail, or if you want to send it to Brandon at gsiguybrandon.com, I would much appreciate it because I can't seem to find a good picture of it, and I can't go out to any of the aircraft in Miami. They don't like people going out to airplanes for no reason just to take a picture. You generally have to be a pilot that's going out to the airplane to actually fly it. Or load it, whatever. So yeah, I can't normally get out to the airplanes. But that is a small hole on the left side of the airplane, just after the L1 door and just prior to the main cargo door on the cargo carriers. But it is there to help evacuate smoke out of the equipment cooling cabinet. So if we think about this, it is called the smoke override valve. Okay, so word association, smoke light, override, opens that valve. And then it is supposed to pull air through it via a reverse flow. Okay, so it reverses the flow of the air in there. It turns off both fans to allow this Venturi to pull the air out of the system. And then hopefully clearing the smoke. Once the smoke is cleared, it's not sensed anymore, the light will extinguish, and then you can go from whatever your QRH says at that point. But the other thing that happens here is this no cooling light. So the no cooling light, what it's for, it is specifically for the override position. So in the override position, the smoke override valve opens. When that happens, a Venturi pulls air through that valve. So there is an airflow sensor in that ductwork going out the side of the airplane through that valve. There's a airflow sensor in there. If it does not sense airflow, if there's no airflow going through it, then it will give the no cooling light after 1 minute. That no cooling light's inhibited for 1 minute when I go to the override position. Okay? So go to override, no cooling is inhibited for 1 minute. And then if it senses airflow, that no cooling light will stay extinguished. If there's no airflow, the no cooling light comes on. What that tells you is you are not getting air through the equipment cooling system. That means that you are going to start losing stuff. And the part of that, it should explain it a little bit in your QRH, but generally what it is non-essential equipment. And again, this is generic terminology. I can't give you everything on the airplane that's considered non-essential. But non-essential equipment will start to fail pretty much immediately. And it's because, obviously it's trying to shed it so it doesn't heat up and doesn't create more problems later. However, essential equipment, you'll be able to fly, navigate, and all that kind of stuff for about 90 minutes. 90 minutes. And usually the QRH says land as soon as practical or find the next suitable airport or something like that. And that's what's going to drive you to, because you're going to start losing stuff. You're not going to be able to fly the airplane, in anything other than probably visual conditions, because you're going to lose your electronics. So, all right. Questions about that, you can send them to me. Again, Brandon at gsiguybrandon.com. Or gsiguybrandon at gmail.com, or training at gsiguybrandon.com. Any of those will get to me in some way, shape, or form if you ever have any questions. Okay, so now we're going to come up here and we're going to look at this. This is our last part. This is our pressurization panel. I'm at 50 minutes. This will probably be a 2-part video, as it probably should have been in the beginning. So I apologize. I said earlier that I was going to make it one video because this is going to be too long. Okay. Cabin altitude control. Again, it's not really a complicated system, but if you don't know what you're doing, you could probably mess yourself up a little bit. First thing is I've got Auto 1, Auto 2, and manual. Okay. These are controllers for the outflow valve itself. The outflow valve on a 7.6 is located on the left side of the airplane, all the way back towards the tail, back behind the bulk cargo door. And it's 2 little flaps that open and close, right? And I'm sure you've seen it on walk-arounds or pictures or something like that. And in Auto 1 or Auto 2, you are using an AC motor. So Auto 1 has its own motor, Auto 2 has its own motor, manual has its own motor. So there are 3 motors that can move the outflow valve, meaning that there are 3 points of failure, which is pretty good versus a single point failure, right? You'd have to have 3 things go wrong before you really lose pressurization in the aircraft. Unless there's a hole somewhere else, but that's a different argument. All right, so Auto 1, Auto 2 are AC, manual is DC, meaning Auto 1 and Auto 2 are faster moving motors than the DC motor. As it's selected right now, Auto 1 would be the one that works. Auto 2 would be automatically switched to if Auto 1 failed. So if Auto 1 fails, it automatically switches. You don't have to move the switch. It automatically does it, and it moves it to Auto 2. If auto 2 were to fail, and then I have 2 auto fails, that auto and op light that's illuminated will then illuminate. And it'll say, hey, your auto is inoperative because both of them failed. Both. So it's an and, not an or. So auto 1 and auto 2 have failed. Or I put it in the manual position. If I put it in the manual position, obviously my auto is inoperative because I'm in manual. Okay. Now, is there a way for me to see that auto 1 or auto 2 have failed before the second one without an auto and op light? Is there another way for me to look and see if auto 1 or auto 2 has failed? And I'm hoping I'm asking that in the correct way to where you understand what I'm saying. I can look at my status page on my iCast. It will tell me if one of my auto controllers has failed. If both of them fail, it upgrades to an iCast, like an actual caution, and I get the auto and op light. But if I only have one fail, that's just a status message, and that's on the status page. So I could look and see it. But the other thing is it automatically checks the opposite controller upon landing. So as soon as you land, if I'm in auto 1 like I am here, the moment I land, auto 2 gets self-tested. And then I'll find out if I have an issue with auto 2. Because if I'm not using it, I won't know. And this is usually one of those things that gets swapped back and forth between auto 1 and auto 2 to limit the duty cycles on it. So, I've heard it where it's odd day, even day, where it's captain FO leg. It all depends on what they're doing, right? I don't care how your company does it. Just switch it back and forth, because that helps lengthen the life of the motor itself. Plus, if you only use auto 1 and over and over and over and over again, when you need auto 2, it may not work. So we just want to make sure. Okay. This, our landing altitude, goes up, goes down. If I want to go to a negative, notice how when I do this, though, notice how the valve up here opens and closes. It's basing, it's because it's basing the information off of what I'm giving it. So as I set my landing altitude, if I want to go negative on some aircraft, if I want to go negative, I actually have to pull that out and turn it to the left at 0 to be able to go negative. But there are some where you don't. You just dial it and it'll go. Up here, we've got our rate. Minimum is 50 feet, and then max is 2,000 feet a minute. This little indice, though, the little caret, that little index mark, that is 500 foot in a climb, 300 foot in a descent per minute. And that's what it will climb to or descend with, to try and alleviate any kind of pressure issues in your ears and that kind of stuff. And that's the normal rate that we're going to use on the airplane. This is our manual control. So if I flip over here to manual and I do this and I hold it in the climb position, you notice what happens with my valve. It goes to the open position. If I go to descend, it closes it. Okay, and then I want you to notice, that's what the actual thing does. It points straight down when it's fully closed, and it'll point straight up when it's fully open. Now, here's the thing. This is almost a full-time job. If you lose your auto 1 and auto 2, keeping manual control of your cabin is difficult when you're in a climb or a descent. It requires constant attention, and it's going to distract whoever's responsible for it. Okay? Just be cautious of that. The big thing is we just want to momentarily bump it into the climb or the descend. We do not want to hold in climb or descend. And the reason we don't want to hold in climb or descend is because we don't want to completely depressurize the airplane or completely overpressurize the airplane by slamming that thing shut or allowing it to open all the way. Okay, it's just that simple, really. Now, in your QRH, in your memory items, there's going to be a section that's going to say rapid depressurization or cabin altitude, right? Cabin altitude or rapid depressurization. In that, You're going to have some steps. They're probably going to say something along the lines of don the oxygen mask, establish crew communications. If there's occupants in the supernumerary compartment, to either go to, either press the main deck alert or, go on with your switches or whatever, depending on your airplane. Number 3 usually kind of has a different look to it. Number 4 is going to say check cabin altitude and rate. 5 is going to say if the cabin's uncontrollable, then descend, as necessary. And you're going to descend to 10,000 feet or the lowest safe altitude, whichever is higher. And then it's going to say to descend, and it's going to talk about how to descend. Basically, it's, spin, spin, push, or was it spin, push, spin, pull, pull. And if you don't know what that means, ask your sim instructor. They'll show it to you. I'm not going to go through it in this one, but that's what you do. Basically, you're pulling the thrust levers to idle, pulling the speed brakes out. You're getting down as fast as you can because you need to get down so you're not depressurized for too long. What I always bring up, and it talks about limiting high structure, if structural integrity is in doubt, limit high maneuvering loads, and then you're supposed to descend at VMO, MMO, that kind of stuff. I know I'm not in the 100% correct order, but I'm just kind of spitballing as I'm going. The question I always ask, and I've asked this to every class that I've ever taught this particular thing in, and it's I talk about step 5 specifically because, step 4 and 5, because 4 usually says check cabin altitude and rate, and 5 says if cabin is uncontrollable. And the question I always ask is, how do I know that the cabin is uncontrollable? How do I know? How do you know? And I'm going to tell you right now, there's not a right or wrong answer. This is just simply to kind of gauge where your head is. So I've heard everything from I'll check the cabin out, the cabin rate, and if the rate is above a certain amount, then I'll do it. If the altitude is above a certain thing, then I'll do it. If it's, whatever. I've heard them come up with everything. I've even heard guys say, well, I just descend. The QRH says to descend. And boy, did I get in the conversation with that guy, because that's just flat wrong. And the main reason I say that's wrong, let's take worst case scenario. I'm flying over the Pacific Ocean. I'm going to Hawaii. Okay? And let's say that I am going at a lower fuel load. It was legal, but I'm at a lower fuel load than what I normally would take because I had to take additional cargo out to Hawaii. Okay? If you're not familiar with ETOPS flying or anything like that, that's fine. Realize ETOPS going out to Hawaii has to be 180. There is no way to do ETOPS 120 to Hawaii. So you have to be ETOPS 180. So just brief description of that. ETOPS 180 means that I'm 180 minutes from any reliable piece of concrete to be able to put the airplane down with one engine inoperative. Okay? So it is one engine operations where I can be 3 hours away from anything. So if we think about the situation where I have a depressurization, and when your flight followers or dispatchers, depending on where you are, when they run your flight plans, they run on 3 different scenarios, and they choose the worst one for their planning. And usually the scenarios are one engine inoperative with a depressurization with both engines operating, or one engine inoperative but not losing pressurization. Okay? Those are your 3 scenarios. Take a guess which one's worse. It's probably not the ones with one engine operating. Because if only one engine is operating, I'm using technically half the fuel. So, not so bad. If I have a depressurization or a decompression, and I have both engines operating, now not only am I using the full fuel of what both engines operating are, now I've got to go down in altitude to 10,000 feet to be able to come off of oxygen, which is going to burn even more fuel, right? So let's think worst case scenario. I'm a cargo carrier. I'm taking off at LA. I'm going out to Hawaii, and I'm 37,000 feet. I get a rapid D, or not a rapid. Well, we won't even say it's a rapid D. We'll say it's cabin altitude, right? Cabin altitude light message come on. I get the warning. The warning horn goes off. I run the QRH. I follow the memory items. I don the oxygen mask. Establish crew communications. And then let's say I don't put any thought into it, whether or not it's controllable or not. I just pull the throttles to idle and I go from 37,000 to 10,000 feet. And I level off at 10,000 feet. And then I decide that I want to troubleshoot. Okay. And then I reach up and I go to manual. And I have full control over the outflow valve. And I have full control over my pressurization. So what did I just do? I just burnt, all this fuel diving down to 10,000 feet. And now I got to burn all this fuel going from 10,000 back up to 37,000 feet. So I got to burn fuel going up another 27,000 feet on a flight that I didn't have a whole hell of a lot of fuel anyway. I had just enough to be legal. Probably not the best decision you could make, in my opinion. Now, if you're a passenger carrier, ignore that whole thing. Because if you're a passenger carrier, not only do you have to deal or worry about you and the flight deck, you got to worry about all the people behind you, right? And it's not good for them if, you're at 37,000 feet screwing around trying to troubleshoot and whatever else, because they're trying to put on oxygen, they're freaking out, they're doing all this. And that's completely understandable that you would rush through the decision and dive down. What I'm saying is that if you're in a situation where cabin altitude light comes on, I get my oxygen on, and it's not climbing at a crazy rate, I have time to go to not only my other auto controller, because maybe it didn't automatically switch, but I can go to my manual controller and I can see if I can get control of the cabin first. Then I'll descend if I need to from there. Because if I'm on oxygen, I'm good. As long as obviously the cabin altitude doesn't get above 18,000, 25,000 for an extended amount of time, then physiologically it can affect me. So those are things that you have to think about. But if I'm at 10, 12,000, like if I'm at 12,000 feet cabin altitude and it's climbing at 200 or 300 feet a minute, 500 feet a minute, I have time. I have absolute time. And if I can go to manual and I can get control of it and I don't have to descend at a 37,000, cool. I just saved all that fuel that I was going to waste descending down to 10,000 before I troubleshoot. Now, is that saying that a pilot needs to know all of this stuff and a pilot needs to be the troubleshoot person and be a maintenance person and understand all this stuff? No, I am not saying that. I am saying that just use a little bit of common sense and understand how the system works. Okay, that's the first thing. If you understand how the system works, you can do things in my opinion, a safer manner than like a crazy freaking idle boards screaming down a 10,000 foot descent or 10,000 feet on a descent and then have to burn all that fuel going back up to your cruising altitude. It's just food for thought. Now, the point of all that is I asked, how would you determine if it was uncontrollable? Let me tell you what I would do. If the cabin altitude light came on, and if the cabin altitude message came on the ICAS, and I get the warning horn, the first place my eyes are going to go is this right here. Right there. That will tell me everything I need to know. Because if I look at it, and we'll see, here I'll unpause. Come on, baby, do it. It won't let me hold it in the descend position. And of course now it's not moving. But if I look at this here and it is anything other than full closed, I might still be able to get control of the airplane, of the pressurization in the airplane. If I look and it is full pegged to the closed position, it is down at the 6 o'clock position, that tells me that that is not going to work. It will not matter what I do with the manual controller because it's as closed as it can get, meaning there is another hole in the airplane. letting this air out and depressurizing me. Where I will argue that a quick decision can be made without having to look at any of this stuff is if I hear a bang, if I hear something happen where all of a sudden there's a rush of air coming out of the airplane, like a rapid depressurization. A rapid depressurization is slightly different than getting a cabin altitude light and message. And the reason for that is usually a rapid depressurization or an explosive rapid depressurization is because of something happening in the hull of the aircraft, and now there is a hole that's not supposed to be there, letting air go out of the airplane. And there's no way to fix that. There's just no way to fix that other than to descend, and now I'm going to have to stay at 10 or 10,000 feet or lowest safe altitude, and then have to deal with it from there. And that's it's all situational dependent. I'm saying under normal circumstances, if I get a cabin altitude light message and it is a slow cabin altitude depressurization, or not even a slow, I don't like saying that either, because it's all situational dependent, because your slow might be defined differently than my slow. 1,000 feet a minute, I could have 7 minutes till I hit 18,000 feet, and maybe 18,000 feet is my comfort level. Whatever. I'm talking about this way more than I thought I would, but it's just one of those things where your decision making can affect on how well you can operate the aircraft. And it kind of shows the reason behind why I do the videos that I do, and why I talk about the systems the way that I talk about them. I've had pilots tell me, well, I don't need to know that. I don't need to know this to operate the airplane. I don't need to know this. I'm not maintenance. I don't troubleshoot the aircraft. I just write it up. And that's fine. If you want to be that kind of pilot and you don't want to know what's happening with your airplane, perfectly fine. Write it up. Be that person. It's perfectly fine. But I encourage you, if you are one of those kind of people, to learn more about the aircraft. You don't have to be a troubleshooter. You don't have to be an A&P. You don't have to be somebody that works for maintenance. But if you know how a system works and you understand what you can do to fix it, and you understand that pushing certain switches do certain things, turning certain switches do certain things, you will be a much more effective communicator when you land. And maintenance says, well, what happened? What's going on? You will sound so much more educated on the aircraft versus, I turned the switch and the button turned on. Nobody wants that. I don't want a pilot that does that. I don't want a pilot that doesn't know what the hell his airplane's doing. That's just me. At this point, I'm done with the overhead panel. I'm just kind of rambling at this point. I'm sorry. So I will cut off my rant, and I will just say, I hope that the videos that I've made for the oral prep help. I hope that if you're going for your type rating, that your oral is easy after watching my videos. I hope that if you have any questions, you will reach out to me and ask. I'm not going to make it up. It's only been like 3 or 4 people that have reached out to me after watching these videos that have asked for help because they didn't understand this, or they wanted to make sure that they understood this, or whatever it is. And that's what I love to do. If you want help, I'll give you help. If you don't want help, good luck. I wish you the best. And everybody that watches these videos, whether you watch it because, I don't know, you're bored and you're on an airplane, you want to learn a little bit about it, and I hope you get something out of these. I really do. I really hope what I say matters to you. I'll just leave it at that. Again, this is video it was going to be video 5. I think it's going to be video 6 by the time I edit it and everything. I'm at an hour and 12 minutes. So I'm going to split this video up into 2 parts. So it'll be part 1, part 2. I know I said in the beginning of the first part of this, it's all going to be one video, but it's just too long for me to have you sit through it. This wraps up the oral prep series for the 767. I'm going to put out a long video of all the videos that I've made for the oral prep together. But that's not going to be done for a little bit because it's going to take a little bit to edit out and whatever. But I'm also going to start doing 7.5 differences videos. I'm going to kind of adjust a little bit. And as long as things go as I'm hoping they will, I may start flying again this summer. And I want to make videos about that too. About the struggles of somebody who's 40 years old trying to get back into something that, I'm trying to wrap my brain around doing this at this age. Not that I'm old, but boy, it's kind of the old dog new trick thing. It's hard. It's really hard. So there's more content coming, I promise. I know it's been slow rolling here the last couple weeks. I've been working in Miami, and then I've had a sick kid and some other stuff, so it's been a little crazy. But again, I really hope you enjoy these videos. If you do, like, share, subscribe, comment, all that kind of stuff. And I'll continue to do what I do. If you have any questions, there's contact information in the description of the video that tells you how to get a hold of me, how you can reach me. Usually if you email me first, I can give you my phone number. You can text me, and then maybe call me and talk that way. I also do Zoom meetings. If you want to do it that way, I can do a Zoom meeting. Anything you need on the 7.6. So outside of that, I hope these are good for you. If they are, let me know. If they're not, keep it to yourself. And we'll talk to you guys soon. See ya.